matrix. Okay, vectors is like a single column matrix. So we have learned about matrix. It is like this, right? But vectors is one column only. So one column, two rows. So the first coordinate, the first value you see here is the x value. Okay, the second value you see here is your y value. So vectors is like a column matrix, one column only. That's why you learn matrix before vectors. Okay, so first thing first, you learn in physics that a scalar, okay, a scalar quantity is a quantity that has only what? Magnitude. Okay, but a vector quantity,
Kieran, can you pass one hard copy though?
for vectors, right? Okay, a vector quantity is something that has both magnitude and direction. So very soon you will learn that if we write vectors, right, there is always an arrow above it, an arrowhead that points in a certain direction. So this tells you to move from origin to A. So in your coordinate geometry plane, right, if I say A is at 3, 5. Okay, my coordinate A is at 3, 5. To move from O to A, so this is my vector OA. To move from O to A, I need to move 3 units to the right. Okay, this one tells me X direction, move how many units. So 3 units to the right, and then I move up by 5 units. So 3, 5 means moving 3 steps here and then go up by 5 steps. So this is moving from O to A. So if I have another point B, example maybe here, I say it's minus 2, okay, minus 1. So this is point B, negative 2, negative 1. So if I want to write the vector OB, I'm moving from O to B now. So I need to move in the X direction 2 units to the left. So when I write minus 2 units. It's going minus 2. Okay, and then I need to move down by 1 unit, so minus 1. So the number tells you how to move your vectors. Okay, so it has a direction. The direction very important. So a vector can be represented by a directed line segment with its direction indicated by an arrow button, arrowhead, sorry. So arrow AB represents the vector with an initial point A, okay, and a terminal, or we can say final, okay, point B. Okay, sometimes instead of writing vectors as A moving to B, example like that, then we say, okay, let this vector be represented by A. Okay, and then they put a curly tail at the bottom. Because A is algebra. But if you put a curly tail at the bottom, it becomes a vector already. So it's just a symbol for it. So we will just write this to represent vector. Or if you are able to bold it, like you go and write it until as if it's like bold, then you can bold it lah. But when I type, I can bold it, but when you draw, you cannot. So you represent by a curly tail. Or we call this thing braces also. Okay, this thing that you see below it is called a braces or curly tail. When it is a vector, so we will use a letter, then with a braces at the bottom. But they will tell you, the question will say, oh, A to B, Then they put a C with a braces below. You know this means vector. Okay, not algebra.
So AB arrow on top is same as A.
Yes. So they will write like that. AB is represented by this. Okay. So I have just told you that vector is usually like a column matrix. So 1 means you move 1 to the right. Okay, 2 means you move 2 units upward. So up is positive, down is negative. Right is positive, left is negative. Like your XY axis like that. Okay, so if they start to draw this line, okay, it means they want you to find the magnitude. Magnitude is like asking you to find the length. So you imagine just now, I gave you this. Okay, if I want you to find the magnitude of the vector OA, this one, what do you think I want you to find? The length of OA. So you use Pythagoras theorem. So just now we know that this one is moving 3 units. So the X is 3. Okay, this one is moving 5 units. So the Y is 5. So can you see this is a A square plus B square? So you take a square root. So to find magnitude is to find the length, and it is using Pythagoras theorem. So whatever this value is, you go and square it. Whatever this value is, you go and square it. Add them up and take a square root. So this is the formula for finding magnitude. Okay, later when we do example, it will be clearer. Okay, because they are telling you every important thing in this one page. Okay, so if I tell you 2 vectors are equal, for example, AB is 3, 5. Okay, the other vector is DC, no, maybe CD is also 3, 5. I can say they are equal because they are in the same direction. Okay, and they have the same magnitude. So they must fulfill 2 things for 2 vectors to be equal. Okay, if I were to draw it out, it will disappear. Okay, next, they are referring to G. So this one now. So G is equivalent to H, not H, negative H. And then what is the matrix? The column matrix that represent this vector?
2, 1, 3, 1.
Any unit I move to the right? No, so 0. And I just go up by 3 units. So it's 0, 3. So I never move left or never move right. So I'm at the same position. Jamil and Sailesh, this one is the beginning of vector. Don't play. Yeah, you laugh and you say something in your eye. Okay, last one is M. M is this one. So we can say is, yes, negative K with the curly braces or the curly tail. And then what is the, okay, don't answer, all don't answer. Sailesh, what is the column matrix that represents M? You see? Jamil? Yeah, but what is the column matrix that represents it? If I'm moving from here to here, how many units did I move to the right and upward? How many units? X direction 2, so this one is 2. Y direction go 1. So your column matrix is 2, 1. So move 2 units to the right, go upward by 1. Okay, now they want magnitude. So magnitude, I don't care the direction because magnitude is length, right? So if I want to find PQ, this one, this is the column matrix. I want to find the magnitude, means I square the x. Okay, and then I square the y, and then I take a square root. So it's equal to 3 units.
Isn't it just Pythagoras?
Which one? Yeah, it's just Pythagoras theorem. So what is this also equal to? It's also equal to F magnitude with the curly braces. Because just now we already state that it's equal. Okay, now we look at G. G is the same thing as negative H. Remember, you need the curly tail. You drop out the curly tail, it means algebra. Okay, so if it's vectors, must have that braces at the bottom. Magnitude means the length. So just now, when we have M, right? I want to know the length of this line. But I know this one is 3 units. I know this one is, no, 2 and 1, sorry. So this one is 2 units. This one is 1 unit. So to find this length, I use Pythagoras theorem. A square plus B square equals to C square. So you take a square root. So this one will give you the length of M. So you are basically squaring the X and the Y. Okay, Okay, Krishvan, how do I find the magnitude of G? This one. Zero, zero. Yeah, 0, 3, yes. But how to find magnitude? 0 square plus 3 square, correct? So it's just 3 units. Is there anything else is equal to? Don't have already, right? Okay, then this one is extra. Not essential. Oh, in fact, is it equal to the DE? It is, no, opposite. It's opposite. So unless I put ED. Okay, so this is a rough idea. You must know how to write down the matrix, when to have curly tail, how to find magnitude. Okay, this is the basic idea. You don't know, then behind all don't know. So better pay attention. Silas, you go there, right? Jamil learn nothing, you know. Then you also never learn anything. That's why cannot sit together. You all don't know what's good for yourself. Who is Elaine?
She's very good at proving her point.
Really? Okay, very good.
She proved that her father needs to be taken care of because he got a second stroke.
Yeah, so I've proven that Silas needs to be taken care of. See, you eat pencil. Okay, this one. How to find magnitude of this vector? So, okay, so square the x and square the y. Silas, you copying or not?
Equal to
What?
5.
Okay, so when we find magnitude, square the x
5.
and then square the y. So we actually wanted to include this in WA2, just the 5.1, writing vectors and finding magnitude, because it's supposed to help you. But I think we decided not to, because no time. Okay, so the length is 5 units. Okay, they say, can you find the magnitude of the vector? No, find the value of A if the magnitude of the vector is 13. Okay, so what you can do is go and find the magnitude first. So A square plus 12 square, square root. They are saying that this thing is equals to 13. So what we can do is we want to solve for the A. So we take square on both sides. When you square both sides, the square root disappears. So we are left with A square plus 144. This is 169. So A square is 25. Or negative 5. When you take square root, there's always two answers, 1 plus, 1 minus. So that's why they gave you a hint, find the values of A.
Maybe we reject the minus.
Don't reject, it's one of the possible answer.
It's not minus, so like 30 seconds left.
Wait. We are waiting.
How?
Do 13 square minus 12 square, that is correct.
Oh, can. Okay, if you want to 13 square minus 12 square, then take square root also can. Okay, so this is the basics of Pythagoras theorem. Why? Okay, since it's like few seconds.
Yes.
Oh, sorry. Okay, this one. So, assuming this is A and this is B, if I want to draw A plus B, let me start from A. A is 3 box to the right. Okay, B is 3 box upwards. Okay, too much. 3 box upwards. So, A plus B is the diagonal here. Yes. Can we what? You can use freehand or ruler. We are not so particular. Okay? So the line that you are essentially drawing is this one. This is the A plus B. Okay, next is they want A minus B. So A is 3 units. Okay, to the right. And then minus B, instead of upward, it goes downwards now. Minus B is the opposite direction. So go downward by 3 units, minus B. So actually what they want you to draw is this diagonal here. A minus B. So this is the answer they want. Okay, it is how you should be moving. So you need to gauge your space. Whether you are moving up or down, then you see where you draw. If it's positive, it goes like that. Like that. Opposite. Yes. Down. Y is going down. So if this one I go opposite, if it's minus A, there is opposite direction, like that. Going right, left. This one going right, opposite. Yeah. How do the? Okay, you see they asked me to move A first, so it's going this direction 3 units. Because A is moving 3 units to the right. The red one is the final one. It's called your resultant vector. You're in physics learn this, right? Like when you move this direction, then next, where is the resultant? Where is your ultimate movement?
So the arrow direction doesn't matter.
Actually, these two you don't draw, never mind. This is the final one they want to see. This is the working to get there. Okay? So it's like topo, right? They tell you, oh, you move in this direction 3 steps, then that direction 3 steps. Your ultimate goal is your movement. Where do you move from the start to the end point? So what I'm interested is the red one only. The black one is the working. Even if you don't draw, it's fine. Okay? So let's look at this one. 2A plus B. So instead of moving 3 units to the right, I need to move 6 units now. So 6 units. 3, 6. So this is 2A. Moving 6 units. 2 blocks of A. And then plus B. So I move upward by 3 units. So this is the resultant that I should get, moving from here to there. So this is 2A plus B. This is what I need to see. Yes. Because I started from here, it must end here. Initial and final. So you must always start from your initial and end at your final. Yeah. Yep. Correct. Yes. This one worth 13 marks? No? No, O level don't ask you to draw, ever. They will ask you to find the vector. They won't ask you to draw, but they will ask you to find the vector. So this drawing is to help you understand how to find the final one. Can. Okay, next one, 2A. 2A is 6 units to the right. And then I know I need to move downwards by 9 units. So I need to plan my space so that I have enough. So I will anticipate that I should start here 6 units. So I decided that this one must start here. So this is my initial point. I just estimate. It can start somewhere else. Okay, and then I want to move downward 9 boxes. So 1B, 2B, 3B. Just make sure you have enough space to move downward by 9. Your initial point may be lower than mine, it doesn't matter. Just make sure that your final one is similar. How it moves are good to have, so that you know where you are ending at. I means initial. This one is your final end point. So you know that moving 2A minus 3B will end you at that point there, the final point there. So this is the final point. Justin and Jamil, you're drawing or not? You all stare at the screen, you'll move on its own, huh? Where's your notes? Now bring. Do you bring your notes? Then use the soft copy in Google Classroom. Vectors. Okay, next one is B minus A. So B is going upward 3 units. So I do B first. B is going upward 3 units. And then they say minus A. A is moving to the right 3 units. Minus A is moving to the left 3 units. So I move to the left 3 units. So this is my initial point. I'm ending here. So this is my movement. B minus A. So I move B first, then I do a minus A. So I started from here and here. So this is my initial and final. Yeah.
How do people count fireworks?
Firework launchers. I don't know why. Why that question?
Because there's people making fireworks.
Yeah,
What profession is
we can find out.
There's supposed to be a teacher scaring me.
I don't make fireworks, so I don't know. Okay, anyway, A represents 3 units to the right? So 2.5 of A means 7.5 units to the right. So I'm going to move 7.5 units. Cannot use weight. Okay, so 2, 4, 6, 7.5. Okay, so this is 2.5A. And then I want to move 9 units upwards. So 3, 3, 3. I end up being here. 3b. So 9 units upwards. So my final resultant vector is this one. So 2.5a plus 3b. That's all. Nine units up. 3, 6, 9. Yeah, correct. 9 box upward. The way Jamil is staring into the screen is very suspicious.
You wish your husband stares at you like the way Jamil stares at the screen. This song last 5 minutes, by the way.
Already? No, now got 7. Okay, so the drawing part shouldn't be difficult. It's just an exercise that O level won't test you like that. They have never tested drawing for vectors before. Okay, so this one. Okay, if you all can still remember, let's say I say moving from point A to point B is represented by 1, 2. Okay, ready? It means if A is here, I will move 1 unit in the X direction. 1 unit. Okay? And I will move 2 units in the positive Y direction to finally reach B. So vectors tell me how to move from A to B. 1 unit and then 2 units upwards. So this vector that you see tells you how many steps to move in the X direction and in the Y. If I want to find the magnitude, this one means finding magnitude or distance. It is using Pythagoras theorem. So actually it's 1 square plus 2 square square root, because this is B, this is A, this is C. So actually it is A square plus B square. So what we do is take the X coordinate here, you square it, add it to the Y coordinate here and you square it, followed by a square root. So when you are finding the length of AB, you are finding Pythagoras theorem to find the distance. Okay, so this is the second thing that we have learned. Okay, next thing. Okay, next thing, when we represent vectors with a letter, we must use the curly tail. This thing we call it the curly tail, or sometimes we call it the braces. So this will represent vector instead of algebra. So make sure you all know how to represent vectors. Must have that curly tail. No curly tail, then wrong already, yeah? Okay, so these were the 3 main things that we learned previous lesson. Let's look at how to draw our page. Fine. So first thing first, this is the vector D and this is the vector C. When they ask you to draw D plus C, we need to follow the direction. So assuming this is my D. Oh, I cannot draw here. I must draw lower. Assuming this is D. Yes. Okay, this one, can I leave you to go and draw? Go back and draw on your own. D plus C, just like that. This one is just 1 rectangle. So if it's 2C, it becomes 2 rectangle. So it's just like that, okay? Sorry, this one is C. Okay, so D plus C is this line. Okay, this one you go home and draw. Okay, I just want to highlight this one. Shh. Treat the vectors like algebra, but you need to draw the braces. So if you are asked to add vectors, you add them like algebra. So this is 2a plus 2b minus 9a plus 3b. This person not keen on learning one. Okay, so you expand, remove the bracket, and then you end up having 5b minus 7a. So this is the vector solution. So you can treat this like algebra, but remember your curly tail. If you don't put in your curly tail, then you will lose the answer mark. So this one, I believe you can also go home and do. Okay, let me thicken my pencil. Sometimes it's thick, sometimes it's not. I don't know what happened. Okay, minus 2 times 2u is minus 4u. So remember to put the curly tail, and then I just copy this over. 4v plus 3u. So treat it as algebra. 4v minus 6v is minus 2v. 3u minus u is minus u. So this is just the answer. So the only difference between this and algebra is there's a curly tail. Okay, the top one, they all copy the last time. Okay, you can draw the top one first. This one is just telling you the direction. O-level will never ask you to draw. In fact, they have never asked you to draw before. But it is to help you see the direction. So you can draw the top first.
Is it even in O-level?
No.
So why not?
No, this one drawing not in O-level, but you need to know how to read direction. So C is diagonal, right, of one rectangle. So when they have 2C, you have 2 rectangles. Can you see that? When you have 2C, you have 2 rectangles like that. So you just follow how they draw. Yeah.
Why your IV got extra?
IV?
Got extra 2 square? Why you color like that?
No, because 1C is like that.
Yeah.
2C is 2 of it.
Yeah.
Yeah lah.
Or you just color for fun?
I double it. Yeah, I color it so that you can see the rectangle. Are you all chanting? Okay, so C, we copy the 5L with the curly tail. Trust me, some of you forget the curly tail or the braces. Okay, this one is 10N. Okay, the negative 3, you apply to all 3 terms here. So you should end up with minus 6L, minus 3M, and plus 6N. So the sign is very important. Make sure y'all don't be careless. So the algebra is 5L minus 6L is minus L. Okay. Then 5M minus 3M is plus 2M. Okay, last one is 10N and 6N. So 16N. So these 3. So final answer is still working like algebra. Just make sure you put the curly tail.
I want a cat one.
Shh. Yes.
What's
What's the
the cat?
what? Yeah, I haven't thought about. Actually, I got lollipop, but if I give you all lollipop, you all eat too long. I must. Today I can buy. Because today I need to go Tampines Mall. Okay, yeah. Okay, AB, they tell you is represented by vector A. So you just change only. Then I have DC. So DC is in opposite direction. So change it to B, minus B. That's all. So when there's a reverse in direction, if CD is B, then DC is negative B. Change in direction, you reverse it. Okay, so this one next thing, 2AB. So the AB I change to A. Another AB here, change to A. There's a BA here. So you need to put in negative A. So that's the only thing when the direction change at a negative sign. So total, total there's 6 A's. Okay, quite okay, huh? Okay, last one is C. To move from C and then move back from D to C, you are going back to the original point. So let's see this one. This is B, right? Moving from C to D is B. Moving from D to C is negative B. Can you see that they become nothing? So you don't write 0, you write 0 with the vector. So it means it goes back to the original point. Which makes sense, you go from C to D, then you come back. So that's why you are back to the original point. So not equals to 0, but equal to the 0 vector.
Is
Yes.
that O or 0? Why you write the O?
0 with this tells you that it's 0, 0. It is not like 0. It is the vector 0. So you must write the curly tail. Yes. Yeah, so this one I can plus minus, but that means I need to simplify one step lah. Then after that write A minus B. Okay, I hope Brennan and Krishvan pair is working out.
I'm dead. I didn't sleep last night.
You didn't sleep last night. I hear a bit of your emotions. So try to catch up on this sleep.
Who does she know?
You see, they look like they teaching each other, meh? So much joy. They studying, meh? Okay, yes. Okay, I move on, Okay, next concept is on parallel vector. Parallel vector. So if I say two vectors are parallel, they are a ratio of each other. For example, I give you an example. If I say A is 1, 2. Okay, if I say A is the vector 1, 2, it means that this vector A is moving in the x direction 1 unit, moving in the y direction 2 units. So the vector A represents 1, 2. Okay, then I have another vector B. I say it's 2, 4. So it means if I draw the vector B, it is 2 units in the x direction and 4 units in the y direction. So what they are trying to tell me is, if I can express B as a ratio of A, then they must be parallel. That means these two vectors must be parallel to each other. So actually, right, we all can see that B is, you take out the 2, this one become 1, 2, right? Like matrices like that, you can multiply one, right? So you take out the 2, it is actually 2 times of A. So if I can show that vector B is a ratio of vector A, they must be parallel to each other. Then I can conclude B is parallel to A, which you can see from the 2 green arrows, they are parallel to each other because the triangle they form are proportional. So this whole sentence here, like some alien language, just means that if I have 2 vectors and I can express them as a multiple of each other, they are parallel. Yeah, K is any constant number lah. So in this case, I found out that it's 2. But it can represent any constant number. Can I? So if I say 3 points are collinear, collinear means lie on the same line. So if I have 3 points, A, B, C, all lie on the same line, I call them collinear points. Collinear points. So when they are collinear, they must be parallel to each other. That means AB is parallel to BC is parallel to AC. Can see that? AB parallel to BC parallel to AC. That's why I can write them to be ratio of each other. Okay? So these 2 paragraphs just telling you these things that I'm telling you now. You were sleeping. Yeah. So as I teach, you try to understand. I waked you. I tried. Yeah? Wait. I bring a cane. I have 2 at home.
Yes.
One for my son, another one still for my son.
Why you cane your son?
I threatened to cane him, but he's not even scared. He offered me his leg.
Because you never actually hit that one. You must actually hit that one.
Okay, next one. If AB is 2A plus B, that means they tell me this. 2A plus B. Okay, and it is parallel to CD. So just now we mentioned that if they are parallel, we can say that they are ratios of each other. So I can write this. AB is equal to K times of CD. Just now, above, they tell us already, right? If they are parallel, I can write that they are a ratio of each other. So I just plug in now. This is my AB. I write it as 2A plus B. Okay, and then CD they say is 3A plus PB. Okay, notice the difference. The K here is an algebra, right? It's a constant number. P here is also an algebra. The rest are vectors. So your curly tail differentiates from the algebra. So you have to put the curly tail at the right place. Okay, if they are equal, it means I can compare them. So I expand this one becomes 3KA. If I expand this one becomes PKB. Ayo, why my pencil suddenly become thin? Sometimes it's the tip, is it?
It's the pressure.
Is it? I put the same pressure, what?
No, because you zoom.
I zoom in then become like that.
Zoom out.
Oh yeah.
I got like that one.
Yeah, first time I know. Okay. So what happens now is I want to do an apple and apple comparison. So 2 must be equal to 3K. The 1 here must be equals to PK. So if I compare them, since they are equal, it tells me that 2 is 3K, so K is 2/3. The second comparison I make is this. This is 1, right? So 1 is equal to pk, and I already know k is 2/3. So I sub k as 2/3. Then p is just 1 divided by 2/3, which is 3/2. So this is how you solve. So you just compare each of them accordingly. Silesh, following? Okay? So when they are parallel, you must write this. They are ratio of each other. That means it is k times of the other vector. And then you just expand in and compare. Okay, but when they say they are equal, that means they are not a ratio of each other. You can change to any other letter you like. A to Z, up to you to choose. I can only multiply k into this, yeah. Because it's k times of it. It's just like just now, when I say it's 2 times of it, I multiply the 2 inside the 2 term. Which one is the what? It doesn't matter, because the k, if it's smaller, it will become half, 1/3. The k will become a smaller number. Yeah, if it's a bigger number, it will be more than 1. If it's smaller, it will become fraction. That's why this one is fraction. Yeah. Can I? Okay, what if they are equal? When they are equal, it's very easy. You can compare them directly. So AB is equal to CD, means 5A plus 6B must be equal to HA plus KB. That means I don't even need to multiply by a multiple. I can compare them already. This one is H. So H is 5. And then this one is 6 because they are equal. Done. Okay, so when they are equal, you can start to compare them already. Don't even need to multiply by a constant. Yeah. Because they are equal, they are not parallel.
Can you move your question 1 to
Question 1 to what?
question 1? You know, I look away for 5 seconds and there's a whole essay on the damn straight.
Like that.
You can move it.
Question 1.
Next question.
Yeah. Yes. There's nothing to expand. They say AB is just 5A plus 6B, so I just replace only. This is my AB. The other one I need to expand because I want to compare them. So I need to expand my K into 3A and my K into PB. Then I can compare the left side with the left side, the right side with the right side. I must simplify first, then I can compare. So this is, the number in front of B is 1. I compare with PK. Because this is the number in front of B. Yeah. So you are just comparing the coefficient. A and B is like a column matrix that they never tell you what it is. So A actually represents some matrix, but they don't want to tell you what it is. So you just leave it as A. Yeah. Okay, last one. Shh. This one, example 3, they already tell you they are equal. So they are asking you to compare this with this. Latika, noisy. So 2K you compare with 6 because they are equal. So 2K must be equal to 6. K must be 3. Okay, then this one, you compare with this. So 1 minus H is -3. So if you try to solve for H, it is 1 plus 3, which is 4. So this one, they are equal, you can straight away compare. Which B? Sorry? Why? I never leave that out. I compare this with this what? They are equal.
Minus h is negative 2.
Then this one, I compare this with this. Because they are equal, these two numbers must be the same. I think some parts of it we need to learn after WA. I don't think we can finish before. Okay, shh. Now they give you two vectors and they ask you to tell them about the relationship between AB and CD. Are they equal? They are not equal for sure, right? Because this is 2A plus B. This is 4A plus 2B. Are they a ratio of each other? Yes, right? So for CD, I realize I can take out the common factor 2. Okay, for this one, I realize I can take out the common factor 2. And then this is actually my AB. So what I've realized is actually CD is 2 times of AB. Okay, when you can prove that it is proportional to it, then you can conclude. Since CD is twice of AB, therefore CD is parallel to AB. That's all. What you can say about it is that they are parallel. So if they are proportional, they are parallel. If they are equal, then everything must be exactly the same. If they are proportional, they are parallel. If they are equal, everything must be the same. It's a ratio of each other. Like this one is 2 times of it. So if you can express this as how many times of the other one, yes. Exactly the same. Everything is the same. How many times of it? Yes. Yeah. Okay, 3 minutes. Breather. 3 minutes breather. Like breathe. How long? 20 minutes, 35. I need one period. Actually, just nice.
Also BK.
Which one BK? Can. So that means I put the K here, then I don't expand this. I expand this. Also can. That means you will write CD is K times of AB. Then you expand here and compare. Also can.
Why?
Student, stop
Yes.
the cheat codes.
What?
Sure, so
That's cheating.
how come this parallel not collinear?
If they share one point in common, that means if let's say this is B, C and
But what
AB,
if I type for
the B is common, right? Then it's collinear.
vegetable, right?
So okay, see this one parallel I prove already, right? But they don't share any common points. So they are 2 separate lines. So I cannot say they're collinear. But if this is AB and this is BC, got 1 point same, right? They are not just parallel, they are the same line.
So what can you explain collinear?
Oh, like, okay, you see, give me. So if I give you like AB is A plus B. Then I give you BC is 2A plus 2B.
Okay.
And I know that this is 2 times of AB, right?
Yeah.
Then I will say BC must be parallel to AB lah.
Yeah.
Okay, because they share one common point,
What's the common?
B.
Oh. Okay.
So the B must be together. The B must be together. So since they share
Can do a trade.
common point B,
They're collinear.
yeah,
Oh, so this one got no common point.
yeah, no common point, so they must be separate line.
This one also got ratio.
Yes, so they are parallel only.
So Collinear depends on the letter.
Yes. If there's one that is the same, then they are same. If not, if they just parallel, won't meet each other. Yeah, nah. They must have a common friend. Yeah, your pen. That's weird.
I don't understand how.
You see, this one 5A equal to HA. They are equal, so the 5 must be equal to H. This one 6B, this one KB. So because they are equal,
Only when they say it's equal.
yeah, then you can compare the A with the A, the B with the B. You see the B with the B. So K must be 6. H must be 5. If not, how to be equal?
So only if it's same then.
You can start comparing.
So like this is not.
Also same, equal. When they are equal, that means the 2K must be equal to 6. The 1 minus H must be equal to minus 3. Because they are exactly the same, so these two must be the same. These two must be the same. Yes.
Yeah. Is this correct?
Is 2 times of xy, so they are parallel. Yeah. Oh, okay, then one more thing. Because they share a common point x, they must be collinear also. Not just parallel, but because they share the common point x, right? So 2 parallel lines got 1 x in common. So they must be the same line.
So they're equal.
No, not equal. When you have 2 parallel lines, right? Originally it's like that. But because this one got x, this one also got x, the x must be together, ma. So this parallel line must be together, means the 3 point must be the same line. That means actually this 3-point line on the same line. So if you can show to me that there's a common point, you have one more thing to say about them is they are collinear points. So it says since they share a common point x, x, y, and w are collinear points. One more statement.
X, Y, and
W are collinear points. So this one is correct already. Just one more. Since they share common point x, y, and w, they are collinear points. One more step. Yeah. So you can say 2 things about them, not just one.
No, this one is interchangeable.
Yes.
Okay. Thank you.
Yeah.
So right.
Mm.
Is it 2A equals 6A? Because there's no constant.
No, they never say it's equal, right? They are not equal, right? Can you find that they are proportional?
Yeah.
So BC is how many times of AB?
3. Yeah, 3.
So they are parallel.
So
Yes.
how to show the equation?
AB is BC is 3 times of AB. Then therefore AB is parallel to BC.
Don't you show equation?
If you want can. If you can see, no need.
Okay.
Yeah. Okay, come back. I gave you 5 accidentally. Last 3. Then maybe we can do the test. Okay, it should be in your mind already. All the data analysis, all the probability. Not much formula to memorize. Okay, let's look at example 5. One look at it, you know they are not equal. In fact, if you compare BC and AB, they are proportional to each other. Can you see that BC, I can take out the common factor 3. And then I have a 2A plus B. So this 2A plus B is actually my AB. So I put in my AB. So I've proven that BC is 3 times of AB. Therefore, BC is parallel to AB. Since BC is 3 times of AB. So this is one thing you can say about it. Okay, but just to bring to your attention, can you see that they share a common point? Common point B. So which means to say, BC is this line here. BC. Okay, BC is here. This is the direction. Then I have another line, AB. Here. Let me use highlighter. AB here. This length or the proportion of it is 3 times the red line. The black line is 3 times of the red line. But because they share a common point B, this point cannot appear at 2 different places, right? It's not like you can superimpose or you just, I don't know, teleport from one point to the other. These 2 points must lie at the same place, right? So actually what happened is this part here. Can I shift? Can I shift this? Okay, never mind. This thing here that you see should actually be here. Because the B is the same point B in that common space. So actually, can you see that this A, B, C, they are lying on the same space, on the same line? So you can comment one more thing. Okay, since they share a common point, B, then you can conclude that points A, B, C are collinear points. So you can comment two things. If you comment only one part, you lose one final mark lah on this comment. So when you observe that the parallel lines got something in common between them, that means they share one common point, then you can add on to tell me they must lie on the same line. These 3 points must lie on the same straight line. These 3 points. Okay? So this is the important part. Jamil, you focusing. Keep looking at the screen. Okay, next one. XW. If you observe carefully, I can take out the common factor 2. So actually it's 2 times of XY.
Why are they collinear?
Because they share a common point B, they must overlap. They must be actually the same line. The B must converge with the other B. They cannot be 2 separate lines on the space. No, it's like this is BC and this is AB. I say that this line is 3 times of this line. That's why they are parallel. But they both stem from B. So there cannot be 2 separate lines. They must be on the same line because B must be that same point. So these 2 points must join together.
So it is the starting and the ending.
If there is one point that they share in common, that means they must stick together. The parallel line is the same line. Okay? So that's the key. Same thing here. I've proven that XW is parallel to XY since they are proportional to each other, or we say they are scalar multiple of each other. Scalar multiple of each other. This is another word for proportional. Why scalar? Scalar is the constant K. That means you can find a constant number that is a multiple of the other vector. Okay, these are just some mathematical terms they like to use, but when you hear it, don't be scared. It just means they are proportional. Okay, so one other conclusion I can make is that since they share the common point X, okay, therefore, points W, X, and Y are collinear points. But if they don't share, then they are just parallel. They have nothing else in common. Okay? So, like just now, we have A, B, and C, D. Now, no common point, so they are not collinear. They are just parallel. So, it just so happened that all these share a common point. That's why you can say they are collinear. These two, then now you know they don't share anything in common. So even they are proportional, they cannot be collinear. Yeah, X is in the middle. It doesn't matter actually, you see your XW is here. Then you can have a XY. Your XY is XY is here. That means actually it's a midpoint. Yeah, so Y is just in the middle of it. This is 2 times, right? This is 2 times. So your Y happens to be in the middle of the line, midpoint.
So as long as there's 2 multiple ones, it's collinear.
If they share a common point, then you can say collinear.
Yeah, that's so multiple.
Yes. Okay, next, between PQ and RS, is there something in common between them? Have. You see RS, I take out half, left with A.
I thought you asked me about collinear. Yeah, have.
Okay, so this one is 4.
I thought it's times 2.
You can times 2 also if you prefer that. Okay, so if you want to work the other way, you can do a 2RS. If you multiply this by 2, also can, 2 ways of looking at this. This one become A plus 4B. So actually 2RS is equal to PQ. Also can. Or if you have seen it in this way, then it's half of PQ. These two are the same. These two are equivalent. You either prove this one or this one. Either one, no need to show both. See what is more comfortable for you. So either case, whether it's half of PQ or whether PQ is twice of RS, you can conclude that RS is parallel to PQ. Okay? But you cannot say they are collinear because they have no common point. PQRS, 4 different points. So that's all you can say. You cannot say anything else. So this one is a common question that O-level like to ask. They will ask you to make 2 comments about the vectors. Or just make comments about the vectors. Then you just have to tell them. Usually it's parallel, not parallel. Collinear, not collinear. Okay, that's it for this part. Okay, 2 units to the right and 3 units upward. So this is the vector I'm representing, the 2, 3 vector. So if I want to find the length, I will usually use this symbol to find magnitude. And how to find it? I square the x-axis and I add up the y-coordinate square. So to find length is like Pythagoras theorem. Okay, although they don't say it, it is just like Pythagoras theorem. So you square the x and then you square the y, you add it up, followed by a square root. No, I'm just recapping what you have learned in 5.1. Okay, so remember 5.1 talks about vector being a column matrix that tells you magnitude and direction. Okay, magnitude means length, means distance, is the same thing. Okay, so now 5.2, we go a little bit deeper into the ratio. So if I tell you AB is 2 units and BC is 3 units, then that means this part here is 2U, this part here is 3U. So they ask you, what's the ratio between AB and CB? What is AB and CB? Ratio. 2 is to? Okay, so ratio we don't care about direction. We just talk about the units, right? So just 2 is to 3 also. So if I reverse the direction, it doesn't matter. Okay, next one, AB and AC. 2 is to 5. Okay, BC is to AC. 3 to 5. Okay, then BA and CA. So the ratio ignores direction. If we are talking about direction, it ignores it. So be careful about that. Yes, vectors. Okay, now we look at A. AB is to BC. Can you tell me what's the ratio of AB is to BC? 2 is to 3. So I can write 2/3. So if I cross the BC back, it's as good as telling me it's 2/3 of BC. So this one I put 2/3 here. Okay. What about AB? This part A. Okay, what about AB is to AC? AB is here. AC is the whole thing. So 2/5. So this is 2/5. Okay? So far, that's it. Let's look at part C. BC compare with AC. So BC is here, compare with AC. So it's 3:5. So put 3/5. So just follow the units. Okay, next one is AB. We compare with the opposite direction CB. So AB is here, CB is opposite. So what do you think is the ratio now? 2 and then over -3. So ratio, we ignore the sign, but when we talk about vectors, the direction comes into play. So because this one I change direction, you must put in the -3. So it becomes -2/3. This minus below, you can write in front, you can write above, it doesn't matter. Okay, it will still be the same value. Okay, last one. AB, I want you to compare with CA. So AB is here, CA is the opposite. So it's what? 2 over -5. Okay, that's all. So this exercise just to tell you when we are talking about vectors, the direction matters. But we are just talking about ratio, the direction don't matter at all. So there's no negative value. We're just talking about the size. Only when we talk about vectors. You see got arrow on top one. Then the change in direction you must put minus. Like this one is moving from C to B, opposite direction. So it's -3 instead of 3. Okay, so we just do one example. It says that D is the midpoint of BC. Means this one cuts it into half. So actually it's 1U and 1U. Okay, so this is 1:1. Okay, next, E is a point on AD such that AE is 2 units. Okay, so what I do is I usually put a small little box there and tell me this is 2 units, this is 3 units. Okay, then this one, those that I circled are all the units. Okay, then next they tell me that AB is A. So that means this one is vector A moving in this direction. I always draw the arrow so I know it's moving in what direction. AC is moving in this direction. So I put the braces at the bottom. So find the vector BC. So you ask yourself, to move from B to C, this is my starting point. This is my ending point. Is there another MRT station or route that I can move so that I can get from B to C? So I can move from B to A first. And then I move from A to C. So what you need to take note of is the interchange. The interchange must be the same. Okay, you must change your stop at the same stop, and then the start and end must match. You must start from the same MRT stop and end at the same one. You started at B, must end at C. So this is the start, this is the end. So you are just finding a route that will get you to the station you want. So BA is -A. The vector BA is opposite direction of this, right? So it's -A, opposite. Then AC is as good as what I want, it's just the B. So my vector is just -A plus B. That's all. Okay, next I want to find DC. DC, I already found BC, this whole thing, BC, right? But now I want to find DC. So how to find this DC? This point is half of the whole line, right? So it cuts it into half. So I just have to half my BC. So my answer is just half of this answer. So you can keep it as that. No need to expand, no need to simplify. Yes. Yeah, you just half of what? Yeah, you can just write half of BC. Need. Must give me this as the answer. Okay, next one is AD. Yeah. Need. Because we can't bold our letters. If you cannot bold it, it means it's algebra. So you put the braces to represent vectors. To differentiate it. Okay, next one is AD. I want to move from A to D. It's the same as moving from A to C. Then C to D. So I'm going to move from A to C. And then C to D. So AC, I already know the vector is B, right? And then CD, I can get from here. CD, I can get from here. So it is the opposite of DC. So just put in minus. Instead of plus, I put in minus. So include the negative sign to show me there is a change in direction here. Krishvan and Sailesh. So you expand. Some become a bit like algebra already. So if you simplify, you get half B plus half A. So treat it like algebra, just that there's a braces at the bottom. Okay, next one is AE. If you look at this line here, the whole AD I have. But AE is 2 units out of 5 units of AD. Can you see that? AD is to AE is to AD is 2 out of 5. 2 units out of the total 5 units. So to find AE, I will 2/5 my AD. So put in this value. Do you need to expand in? No need. You can leave your answer like that. If you want to expand, also can. Okay, last one. DE over DA is 3 units out of 5. Okay, this one is 3 units out of the whole thing 5. So to find DE, I need to 3/5 my DA. So DA is this answer, but change direction. So you put in this value, but you change the direction. So become minus half B minus half A. So you go expand and simplify. Okay, I quickly write because Mr. Chua is coming, right? You all got some non-weighted assessment. Okay, so this is the answer. Okay, we continue from next lesson. Please bring your vectors notes, last chapter. At least 8 marks out of 90 marks in paper 2 will be this. So make sure you also can get. Okay, your paper can bring home. Mr. Chua is here. Let's continue next lesson. Is given by the vector A. And moving from A to D is given by the vector D. So can you find what is BC? So ask yourself, if these two are parallel, same direction, then they have the same vector. So that means this is also D. So I can write down BC is also D. Yes. This one must be the same. Oh, that one for matrix. Yeah. Okay. Next one is CD. Moving from C to D.
Minus negative
So remember change direction. So moving from C to D, it's a negative A. So although it's same vector but opposite direction, so reverse the sign. Yun, Vera, quickly find your focus. Next one
A
is,
plus B.
next one I want is AC.
A plus B.
So like that. So remember, my starting station is A, my ending point must be at D. So imagine yourself moving from here and then finally here. So AC is the same as A to B and B to C. So I will add A to D. So that's how you do. Okay, look at it like the
This one.
movement.
Can you imagine this Sunday the entire day I do this?
Sunday. Okay, next one is B, D. I want to move from B to D, this direction. So can you see that it's the same as moving this way? So it's the same as moving from B to C and then C to D. So BC is just D, CD is minus A. Okay?
I think this is called development.
This is them or something?
No, it wasn't. Lazy.
Okay, next one is AE. I want to move from A to E here. I want to move from A to E. So what do you think? Can, same. Okay, so AE, if you can see, it is half of AC. Can you see that this one will cut it into half? The diagonal meet at the midpoint, right? So it will cut it into half. So to find AE, it will be half of my AC. So I already got my AC answer I put in. So you just write half, then A plus D will do. Okay, so it's finding the relationship. D minus A. Okay, this one. To move from B to D like this is the same as moving from B to C. Okay, and then C to D.
What's the double line in the A to C? The double.
It's just the direction. I just differentiate it by drawing double arrow, so you know there's a difference. Can see or not? Because this is D, this is minus A. I just add them up only.
Does AE equal to EC?
This one is A ma, so opposite is minus
This
A.
one. This one.
So I only added them up.
This one.
Wait, I finished her question. Yeah, what's yours?
Does AE equals to EC?
Does AE equals to AC? No, it's half of it.
AE equals to EC.
Yes, it is. So, Kiran asked a question, is AE and EC the same thing? Yes. Because this is the midpoint. Same direction, half of the vector. Because I never changed the direction. It's AD and BC. If it's CD, then I must reverse. I must put minus D. You mean this one? This one is AB, right? But if I DC, it's A. But now I'm CD, opposite direction. Yeah. Okay, last one is DE. DE is this direction. Okay, this direction. So can you see that DE is half of DB? It's half of the entire line. Right? It's just midpoint. So DB I have is here. But the only thing is it is of opposite direction. So I need to reverse my BD. So to reverse it, you need to reverse the sign of all these things. So it becomes minus D plus A. Okay? So this is the, okay, DB is minus BD. Correct or not? Opposite, right? So I put in my value for BD it is negative of D minus A. So can you see that I change my value to this? Negative half.
Yeah, the second.
If you want to put negative half in front also can.
Is it? What you write?
Where negative half?
No, Miss Wang. Your second line. But
Yeah.
not.
Half times negative BD.
Okay, because your equation one longer. I thought you connect.
No.
So why do you have to change to negative?
Because I changed the direction. Can. This is BD, but this is DB. Opposite direction, you must negate it. Make it negative. Silas, you looking for what? You all saw the Boys to Men, right? That guy searched for his NRIC the whole 2 years until he passed out. So like you like that, O-level finish already, then you find your pencil case. Okay, so remember, if it's the reverse direction, make it opposite. So like AB is A, right? Then BA is negative A. Just add a negative to it to reverse the direction. Okay, the rest is just algebra. Just simplify like algebra. Okay, but the direction is important. I think 1, 2, this is the third one, fourth one, fifth one, and the last one, sixth one. Okay?
Sir, why do you have to complicate it like that? Can't you just like follow the line?
2
You start from D, then move to A, then A, move to B.
for which one?
This one.
You want to
Why
find
do you do all this?
No, E is half of the point only. So unless you do this plus this one, also can. But you cannot go here, it doesn't end here.
So I do this.
But you must have this lah. Then you can use your answer from here and sub in also can. Okay, next one The consistent math result person.
Too far.
Sister too far.
I say don't talk to me already.
See, I stopped talking to you.
Yeah, good. Okay, this one. There are a few scenarios that I need you all to memorize. Okay? If you have triangles with common height, I just want you to focus on this one and the other one, the blue and the red triangle. These two triangles both has the common height h. Agree? Okay, both blue triangle and the red triangle has the common height yellow one. Okay, so if I want to find the ratio of their area, let's say area of the blue one. Okay, area 1, it is half times PQ, I call this B1 times the height h. This is for the blue triangle. Then the red one, it is also half times this base now, I call it base 2 times the same height because they have the same height. So if I want their ratio, can you see that the half and the height cancel out? So if I ask you for the ratio of the blue triangle to the red one, you can straight away tell me it is 3:8. That's all.
But Joe, if you don't even use the half to the height, right, then you just compare this.
Can. So once you see triangle with common height, you straight away can tell me the ratio of the area. That means the blue triangle's area is 3 units, and then the red triangle's area is 8 units. So what is the units for the whole triangle? 11. Can you understand or not? Cannot. So another time, if I have 2 triangles, and then I split it into half, not exact half, but what I tell you is this is 2, and this part here is 6 cm. Okay, so then I ask you, what is the ratio of the area of A1 is to A2? Yes, that's all you need to know. So it is 2:6, then you give me 1/3. What if I ask for the area 1 and the combined area of these two triangles? Then it's 2:8. So it's just 1/4. So that's how you find ratio of their area if it is triangles with common height. So no matter how you split it like that, you split it right in the middle. No matter what, you will compare their base. So this is B1, B2, B1, B2. All you need to tell me is what is the ratio of their base. It's the same as the ratio of their area of triangle. Cannot. So this is one scenario. So for vectors, there is also one part of the question that asks you for ratio of area. So this is the type of question they can ask you. Okay, another type is parallelogram. Oh, actually this one, how should I put it? Okay, I just tell you. This one I tell you first. Okay, so if I have parallelogram, right? Same thing, two triangle, A1 and then the other triangle, A2. Can you see that both triangle has the same height, H? No matter how you orientate them, the perpendicular height for the blue one and the black one is H. Can you see that? So these two triangles are triangles with common height as well. So when I want the ratio of A1 is to A2, I should compare B1 with B2. So what is the ratio? 6:6. So actually it's just 1. That means they are exactly the same. Which is true because if you have a parallelogram, you split it into half, the two triangles are exactly the same. So the ratio is just 1 or 1:1.
So for this one, will they ask like question like prove that this is a parallel?
They won't say proof, they will say find the ratio of the two triangles. Yes. You can just put 1. Yeah. Need not be fraction. Okay, then what if I say I want A1 and the whole parallelogram? What should it be? 6 and then the 6 plus 6. So it's just half. Makes sense, right? Because this is one piece. The whole parallelogram is 2 times of it. So it's 1:2. Okay? So these are just extension of triangle with common height. Same thing for trapezium. If I draw this as one triangle, the second one is here. They also share the same common height. So what is the ratio of A1 is to A2? A1 is 8, the base is 8, and then A2 is 5. So the ratio is just 8:5. You just compare the base will do. As long as the height is the same, then we just compare the base. Okay, so you just have to remember this is one type of question, triangles with common height. This is type 1. I only have 2 types.
I have calculator to use.
Okay, I only have 2 types.
You don't need the calculator.
Yeah, it doesn't matter. So whether I put the triangle in a parallelogram or trapezium,
Every time I'm sitting
or if I want A1 is to A2, then must be 8/5. Yeah. Okay, can Okay, another scenario. Okay, we try this one first. A2 is the area of the parallelogram, means the whole thing. Okay, A2 is the whole thing. That's what they clarify. A2 is the whole thing. A1 is just ADE, this part. So they ask you, what is the ratio between A1 and A2? Is it 2:5? So first thing I want you to see is this. You split it into half first, the one that you are comfortable with. Let's call this part A3. Okay? So A1 and A3 is 2:3, correct? Correct or not?
A is a bit hard.
Correct? So A1 is 2 units, but A3 is 3 units. So what is the whole parallelogram's unit? What is the whole parallel? Okay, so A1 is 2 units. Okay, I write like that. A3 is 3 units. What about the parallelogram? Half of it is how many units? 5, right? So parallelogram, 10. So 2 plus 3, this is half of it. This is half of it, you times 2. So the whole parallelogram is 10 units. So all they want to see is A1 is 2. The whole parallelogram is 10. So the ratio is 1:5. So you just need to be able to tell them the ratio. You see this part here? Let me highlight in color. This one is 2 units. Okay, and then A3, the blue one, is 3 units. So half of the parallelogram is 5 units, correct or not? Then the whole parallelogram, 10. That's why I get 10.
Oh.
Yeah.
So, but isn't the 3 for A2?
3 is for A3, the blue one only. A2 is the whole thing. They purposely make it a bit confusing. A2 is the whole thing.
So then, whatever length is for DC is for A2.
Yes. Okay, so this one is one way you can look at it. Okay, then now let's look at it for real. They say PQ is 1 unit. So let's call this 1U. We don't need the actual length, we just need to know the ratio, right? And then QR is 3U. So this part here is 3 unit. This part here is 1 unit. So question asks you, what is the ratio of PQ is to PR? 1:4. So this one is done. Because you combine the whole thing. Okay, now I want PSQ, which is this one, the red triangle. And then I want you to compare with PSR, the whole triangle. So what is the ratio? The red to the black one. Compare the base will do. So the red one has base 1. What is the black one's base? 4. So it's just 1/4.
So is height always the same?
Yes, the height is always the same for this example. Okay, next one I want SQR. SQR is the blue triangle. I want to compare with the black one. So what should it be? 3/4. That's all. Okay? So when they write like that, you give your answer in ratio. But when they write like this, you give your answer in fraction. So this one is in fraction. This one expressed like a ratio. You look at the question to see what they want. Yun and Ria, are you all focusing? Too happy already there. Okay, so this is ratio of area. Quite direct, you just have to compare the base and see whether they want the big triangle or the separate ones. Can I? Okay, wait, I to make sure I need to ask a question. Sailesh?
And you're not gonna know how.
What is the ratio of A1 is to A2?
I'm predicting.
Good. A1 is to the whole thing?
Challenging your knowledge.
Okay, good. Can. Just needed to check that. Okay, now, what if we have similar triangle? Okay, so similar triangle, if you all can still remember, we split it like that. Can you all still remember your similar triangle? Sec 3. Do you all remember what is A1 is to A2? A1 is the small triangle. A2 is the whole thing. How do we find the ratio of A1 is to A2? Can you all still remember or not?
L1 over L2.
L1 over L2 square. So for ratio of similar triangle, you need to square the ratio. Different from just now, we just compare the base, right? This one you need to square. So just take note, if it's similar triangle, square the ratio. So now they say BC and DE, they are parallel lines. So these two are parallel lines. So let me just draw these two parallel lines. And then they say the ratio of BC is to DE is 2U and 5U. Okay, that's what they tell me. So they say, can you tell me what's the ratio of AB and AD, the whole thing? What is the ratio of AB and AD? What is the ratio?
2 over 5. 5 or 7? It's not 5.
You want the whole thing?
Remember when we have similar triangle, if I draw them separate, if this is 2 is to 5, what is this?
2 is to
Also 2 is to 5. So all three sides will be 2 is to 5, 2 is to 5, 2 is to 5. So same thing here. This one should also be 2U. The whole thing should also be 5U. So this is also 2 is to 5.
but the question they never say.
They will tell you they are similar triangles. Or you have to prove part A, they are similar triangles first.
They can
Yeah. Remember by AA test, since, okay, so let's say I have a part 1, since BC is parallel to DE, therefore these two angles are corresponding angles. Remember that? And then because these two are corresponding angles, you can conclude by AA test. Angle C equals to angle E. By AA test, triangle ABC is similar to triangle ADE. So this one, they will ask you to prove part A, but I never show here because we just want to compare the ratio in vectors. So how to find AC is to AE? AC also 2 is to 5. So this one 2, this one 5. So 2 is to 5. What about AC and CE? 2 is to 3.
genius.
Okay? So don't be scared. It's the same thing. Next one, I want triangle ABC and triangle ADE. So this is A1. I want to compare the big one. Angle. This one means angle. If you don't like, you write like that also can. Same. Okay?
All square.
What is the area of ABC is to ADE?
Is the formula?
This one. Yes, 2 over 5 square. So when you square it, you get 4 out of 25. So that means this small gray triangle is 4 units. The big one is 25 units. Yes. Because that one is not similar triangle, they are triangle with common height. When we do a half times base times height, they cancel out. So their ratio is just their base. Because those two got same height. This one don't have same height, Yes.
What?
Only applies to similar triangles.
Yes. Then you square the ratio.
So the before one is not similar.
No. The before one is triangle with common height. They are not similar. Okay, next one is ABC and BCDE. That means I want this trapezium here.
2 is 2.
Remember just now I said this one is 4 units.
Yeah.
The whole thing is 25. Yes. So it's 4. And then the bottom is 25 minus that 4. So it's 4 out of 21. Okay? Can. So you just have to break it up into parts. What about the trapezium with the whole triangle? What about the trapezium with the whole triangle? What out of what? 21. Out of the whole thing, 25. Okay? So no matter which part they ask you, you need to ask yourself, is this common height or similar triangle? Yes. Sorry? E? The whole thing, just now we found out is 25. But this tiny part here is 4. Because we square it. Part E, right? So if the whole thing is 25, this is 4. Then this is 25 minus 4, which is 21. Okay, next one is ADC and ADE. So I want you to look at it a bit differently now. Let's draw the triangle out. Sometimes they are not so clear, right? So let's draw out the triangle. They want ADC, which is this one, and ADE, the whole thing. What do you think? What kind of triangle is this?
I don't know.
What kind of triangle is this? Just now we say we have before, right? Triangle with common height.
Right angle triangle.
No. It's triangle with common height. Okay? So if it's triangle with common height, what is the area of the red one?
Half time.
2 units, right? This one, 2 units. So what is the whole thing? What is the area of the whole thing? If this is 2, what is the whole thing?
5.
Just 5.
By its area.
So by let's say area.
Ratio. Remember, just now we just did this, right? If this is 2, this whole thing is 5. Then the ratio of this area is to this one is 2:3. So if this is 2 unit, this is 3 unit, the whole thing is 5 unit.
So that means in this one they are not similar.
They are not similar anymore. So we look at it like a triangle with common height. This is 2. The whole thing is 5. Okay, you can forget about the 25 here. Because 25 is comparing the 2 similar triangle here. This one is the 4. The whole thing is the 25. We are comparing. Remember, it's ratio. The units for this one is different from the units of this one. The 1 unit is different size. So you cannot compare them already. When I'm looking at the pink one with the blue one, I look at 2 is to the whole thing 5. It is triangle with common height.
So why suddenly got 4?
I got 4. Oh no, this one is if I split it. So don't ignore this one. Okay, what about the red one with the green one? What about the red one with the green one? Yes, just 2:3. Because just compare the base will do. Because they are triangles with common height. So whether it's similar triangles or triangles with common height, whether need to square or don't need to square. So just need to know the difference between the two. Okay, last one. This one, right? They purposely want you to start mixing things up. They want you to compare ABC with DEC. That means the black one with the green one. So they want you to overlap the answer you have from just now. So I want you to look at these two. This one I forgot to write, is it? What is ABC and ADC? Oh, I haven't do. Okay, wait
I think you also
ABC
spacing out already.
and ADC. Okay, wait. How should I... Okay, I don't want to confuse you. I want to find the relationship between the answer on top. Okay, ABC can be found here. Okay, and then ADE. Okay, here, these two. Okay, I want you to see very carefully. This one, I want to split it into two fractions. Area of triangle ABC on top, and then area of triangle ADC at the bottom. Isn't this the same thing as this if I multiply?
Yeah.
But I need these two to cancel out. So if I ask you to refer to these two, they share something in common. What is the triangle they share in common? ADE. So I'm going to write the area of triangle ADE inside. Can you see this ratio? I can get from here. ABC and ADE is 4 out of 25. Okay, but this one, ADC and ADE, I want the opposite. Okay, I want the opposite. So this one, instead of 2 over 5, is 5 over 2. So they just want you to multiply these two. Press the calculator, and then your answer will give you 2:5. Okay? So whatever that you have found on top, there is a relationship that you can find and multiply and simplify. That's why they put stars there, because it's meant to be tougher. But you can find your answer from the earlier part. Same thing here. This one, ABC and DEC. Where is my DEC? This one.
How is this cyber bully his people like?
Okay, I want you to compare this one. These two blue ones. And I want it to relate to this one. So same thing, I'm gonna split the numerator and the denominator up. So I need to find something they have in common that I can cancel out. So if you look at this, the DEC is the common one.
No, it's ADC.
Oh, ADC, sorry. ADC. My eyes. Okay? Yes. It was from here, but it's reverse.
It's kind of how water works.
I cancel, right? No, you just press calculator, this whole thing. 4 over 25 times 5 over 2, you will get 2/5, right? You check 4 over 25 times 5 over 2. Yeah, 2 over 5.
Like if I'm in the morning, I force myself to do cold water so I wake up. By heat.
No, this is 4 over 25.
But if
I
it's
simplify.
Like in the afternoon,
I simplify, I cancel. So you can ignore this one. You can just press calculator directly. Okay, you can just press calculator directly. Okay, so let me put in the values. ABC and ADC, I know the answer is 2/5, so I put in here 2/5. Then ADC and DEC is 2/3, so I just put this in, and then I get 4 out of 15. So unfortunately or fortunately, this last two is the difficult one. This last two is the difficult one that you need to find the relationship between the top answers. Okay, but will O-level ask until so difficult? Over the years, not really. But many years, one time they will ask one part that is difficult and it's 1 mark only. So don't have to worry too much about these 2-star question.
But that one.
But every mark counts.
Yeah, but
Yeah, but
all
that
these
one
you
mark
must get lah.
difference between-
All these you must get.
But that 1 mark could be a difference between A1 and A2, you know.
So, like one question how many marks?
C6 and
Vectors, the whole question can be 8-9 marks one. Yeah, but it's like only 1 or 2 questions in the whole 2 papers. You must have effort, noise, is it?
Sure.
Yeah.
So like, you can't mix the ratios or anything like that, right?
I cannot.
So
Yeah.
can you explain the bell curve?
The bell curve is a myth.
Oh, it's actually
It's not a
myth.
myth.
I knew
bro.
it's a myth.
It's the truth.
It's a myth. Like I say, we adjust the marking scheme. If it is very easy for everybody, we will make it very difficult to get that mark.
Oh, so this is
But the A1 is still a 75.
so
Okay, next one is position vector. Okay, listen Shh. So the whole thing, right, just now, other than the direction, the next thing that is important is position vector. Because O-level will ask one about the direction and the area, and then ask one about position vector, which you will see that in the O-level paper 1. Position vector, they like to test in paper 1.
Just like the line.
Okay, so I'm not going to ask you to draw anymore because O-level won't ask you to draw. I'm going to zoom in directly to this. When they tell you, okay, listen shh. When they tell you point A on the coordinate plane, okay, when they tell you point A is 4, 2, then you will mark out point A here, right? So when they give you coordinate, they are giving you position vector. Okay, listen to this carefully. Real. Silesh is so engrossed in what you all are watching. Okay, so this one, listen, it's important. Listen, Silesh. Look at your teacher's screen, not your friend's screen. Okay, so if I give you coordinate, I'm giving you position vector. Please remember that. So position vector means what? To move from the origin to point A, I need to move 4 units to the left in the x direction and 2 units upward. So I'm giving you position vector from O to A. It is 4, 2. It is a column matrix. So when I tell you A is this coordinate, I'm telling you it is this column matrix. They don't write like that for you one. You must be able to translate yourself. Okay, next one. B is minus 3, 1. Meaning is somewhere here, minus 3.
this one.
And then 1 here. B is here. That one no need to draw because really O-level don't test you on that. And we have drawn enough. Okay, so OB is moving from O to B. You move in the negative x direction 3 units and then you go upward 1 unit. So when they tell you this, they are telling you moving from O to B is the column matrix minus 3, 1. So when they tell you coordinate, they are telling you position vector. So these two are the answer for this one. Okay, then finally they say, can you tell me how to find AB? If I want to move from A to B, I need an interchange. What is the interchange point? O. So that means I must start from A, go to O, and then from O, then I move to B. My start and end must be the same as what they want you to find. So I put in my AO now. I have OA, I don't have AO. So what do you think I need to do to this? Reverse the sign, right? So it becomes minus 4, minus 2. So you reverse this. AO becomes negative of OA. Remember that. So it's minus 4 and minus 2. Okay, when you change the direction, you reverse the sign. So OB I know, then the rest is just matrix. Add the 2 and 3 together. Yes. OA. Yeah. Okay, so this is minus 1. So this is my answer for vector AB. So this kind can go up to part 1, they ask you to find this, give you 2 mark. Part 2, they ask you to find the length, another 2 mark. So 4 mark or 3 mark question, make sure you can do. Okay, so now they say, I give you this. Can you tell me what's the coordinate of D? What's the coordinate of D, Jamil? Jamil? Remember, coordinate tells you position vector. So this one you go backwards. Don't reverse, same. Exactly what you see there. So 5 minus 2. So when they ask you for coordinates, read from the column matrix and put it back into a coordinate. It's the same thing. 1 mark, like that. Please do properly. Okay, and then I want to find OE. So you ask yourself, they give you DE, they give you OD. What is the intermediate station if you want to start and end from O to E? What is the interchange? D. So just put in the D first. So remember, your start and end must be the same thing, OE. The interchange must be the same. So I put in my OD now. My OD is 5 minus 2. My DE is 3, 6. Then it's just column matrix addition. So 8 and 4. Done. Okay, so it is like matrix addition, but do it carefully with the direction in mind. Okay, important You like floating like... If I'm a frog, you know I got the tongue very long like that, I'll use my tongue and slap the head. I think I can be an animator. Like I got image in my mind.
Yeah, but you draw it.
I can't draw. Then I will engage somebody to create it. I just talk.
Story writer.
Oh, story writer. Okay.
Isn't that what the government orders?
What? Are you on, Krishna?
Sorry, think too far.
Language very interesting. Are you on? Is that... Yeah?
What's your English?
Should I tell her what it is?
Oh yeah, what's your English name? Is it Jessica?
She's not Miss Wang.
My surname is Huang. I'm not Teh.
Jin Huang.
Call me whatever. Call me whatever.
Elaine.
Okay, stop it.
Adeline.
Yes.
Okay, I'm moving on. Last question.
I know.
Then at least we finish 5.3. Okay, PQ and OP, I want coordinates of Q. It's as good as asking you what is OQ. Okay, so remember I must start from O, end at Q. What is the interchange here? P. So I put in my OP, 1, 2. Don't put a line here, it is a matrix.
It's a fraction.
Y'all, I don't know why y'all will do all sorts of things.
No, genuinely.
This one is 2, 5. I put in.
Miss Wang is generally counterintuitive.
So 1 plus 2 is 3, 2 plus 5 is 7. So my coordinate Q is... Sailesh, what's my coordinate Q? My soul go to the wall already. What is the coordinate of Q? Read from here. Okay. So there's a variety show that has kids says the darnest thing, right?
The timer.
Yeah, they say darnest.
What?
Lucky I'm not a language teacher. Okay, I want to find the magnitude. When you see this, it means they want you to find the magnitude or the length or the distance. Okay, so I want to find the distance of PR. I need to have the vector first. So I must start from P, N at R. What is the interchange? O because I have OR. So OR is 4 minus 1. So I put in the O. So PO is the opposite of this. Jamil, what is PO? This one. I want PO, I don't want OP. Don't change the position. Stay where they are. So it's what? Yeah, but I want to reverse the direction. Reverse means you make it negative.
Just give him the answer, Miss Huang.
-1 and -2. So remember, this one I must write one more time. PO is negative of OP. So when I put in the negative, these two become -1 and -2. So put this as -1, -2. Don't swap the XY. When I say reverse, not swap, just change the sign to the opposite one. Then OR is here. So I get 3 minus 3. So how to find the magnitude? You use Pythagoras. Square the x and then square the y and then you do a square root. So what's the answer? You leave it to 3SF.
So this formula.
Yeah. No, it's not 9. I mean I yeah to Fishvan. What is the answer? What is square root 18?
9.
I'm very sure it's not.
2.
It's 3 square root 2.
6.
Okay, units. Okay, 3SF. So I'm telling you, this is not difficult at all. You just need to remember the rules. It is 4 marks in O level. Don't believe, go and relook at your paper 1 for the past 3 years we do and go and do the vector question. It's just like that. I'm perfect on the timing. I'm so proud of myself. Okay, tomorrow please bring the vectors notes. Let's complete the last part. Okay, first one, if I'm writing vectors, if I want to move from point A to point B, okay, I need to make sure that my start and my end point must be the same. So that means if I choose another route to get to my destination, my start and my end must be the same. Then I need to look for interchange, an interchange station between them. Let's say AP and then must be PB. So how does it look like? Is that if I want to move from A to B and this station is under renovation, I cannot go through this route, then I have to go through an interchange. So that's why it's AP plus PB. It will still end me off at the same station. So this is the first thing we talked about yesterday. Okay, second thing is about ratio of areas. So if I have case 1, got 2 cases. So case 1 is when I have triangles with common height. Justin, you listening or not? Okay, triangles with common height means if I have a triangle and I split it up into 2, okay, both of them will share the same height of H. So if I look at the area of triangle of this slice versus the area of triangle of the other slice, so let's call them A1, A2. Okay, then the ratio of their area will be the ratio of their base. So that means if I want the ratio of the area of A1 is to A2, it will be half times base times height, half times base times height, and then because these two will cancel out, it is the same as the ratio of their base. So ratio of this area is to this is the same as B1 is to B2. That's the same thing. Okay? And then we also agree that if we have a parallelogram, okay, it is also triangles with common height. Just that the two of them are inverted. So one of it is here. Yeah? Today? Okay, we will sing you a song later. Let me finish this. You need a dance?
Yes.
Okay, I will ask Rebecca. Then I will ask, Parish not here, right? I will ask Parish to do his specialty.
No, we still got try.
Oh yeah. Later. I make you a show. Okay? But yeah, we must feature Parish TikTok video. He showed me. I was like, why you do that to yourself? Okay, so between the two area, right? A1 and A2.
Miss Wan, can you imagine? I scrolling on my phone happy, right? Then I see Parish TikTok. Then I see another one. I see another one.
So your feet got
All
Parish.
Parish,
Oh my god. Okay, so this is B1. This is B2. Because they have the common height, it will also cancel out. So A1 is to A2 is also B1 is to B2. So the last case is if it is a trapezium. Okay, if I were to split this into two triangles, it will also work the same way. So these three are similar cases of triangles with common height. Okay, triangles with common height. We still have some examples to cover, then we are done. Flourish, I still haven't looked at the package. I was meeting a parent just now. Okay, so this one is B1, B2, secret. This is the height. So same thing, A1 is to A2 is B1 is to B2, same thing. So these three cases are all triangles with common height. So yesterday we talked about that. So the second case is similar triangles. So case 2, similar triangles. So similar triangles either look like a stacked triangle like this, or sometimes it looks like a ribbon. Okay, but the thing about them is there must be a pair of parallel lines. Then it can be similar. Because why? By AA test, these two are corresponding angles. These two are corresponding angles. So the small and the big triangle will be similar. Same thing here, if you have a parallel line, you will have alternate angles here and here. So by AA test, these two triangles confirm parallel. Okay? So when you have similar triangle, remember, A1 is the small triangle here. This small one, and then A2 is the whole thing. The whole thing. So A1 is to A2. It's B1 is to B2. Same thing, but the difference is you need to square. So for similar triangles, the ratio, you have to square the ratio of the sides. Same thing here. If let's say this one is B1, B2, and I call this triangle A1, this one triangle A2. Okay, I recap, I don't say you never learned before. Okay, so A1 is to A2 will be B1 is to B2 square. So these two are similar triangles. When you see that, when they ask you to find the ratio of the area, remember to square the ratio. Justin, you listening or not? I keep looking at your screen. Justin Gao. You see, he's so you put earpiece some more. You want to fail math, is it?
Why not ask him if you want to become my nurse?
I scared.
Okay.
Because one day I need to go to the hospital. He's a what? Inventor. Invent what?
You need to understand the joke. The joke is the F students are inventors.
Okay, I will find it after class. Okay, last one that we learned yesterday is position vector. So position vector is related to coordinates. So if I tell you that the coordinate of A is 4, 1, on the xy plane, 4, 1 is here. So I mark out the point A is the same as the position vector from the origin to A is 4 units to the left and 1 unit upward. So it's given by the column matrix. So when they give you coordinate, you have position vector. It's like they are telling you the position vector. Okay, if I give you coordinate B being -4 and 3, let's say here, -4, then 3 maybe here. So OB, right? So it's like I'm telling you OB is -4 to the left and then 3 units upward. So the coordinates and the position vector, they work together. So with that, I can ask you, what is AB? Then we use the concept we learned at the very beginning. Start from A, must end at B. So I must look for interchange between them. And if I look here, it must be O. So that means in order to move from A to B, right, this line here, in order for me to move from here to here, I must move from A to O and then O to B. Okay, so that's another route to reach my endpoint. So AO is the reverse of OA. So this one you need to know. If I want to find AO is -OA. So instead of 4 and 1, it is -4 and -1. And then OB I know is -4 and 3. You just have to add them up. This is the column matrix for the vector AB. If I ask for the magnitude, this symbol means magnitude or magnitude or length or distance. It all means the same thing. So imagine if this is a tuakaso, -8 here, 2 unit upward. To find the length here, you will square the x coordinate, square the y coordinate, add them up, divide by, take a square root. So you use Pythagoras theorem to find the length. So these are the three things that I discussed yesterday. Okay, so make sure you have that at the back of your mind. Position vector, magnitude, how to connect different vectors together, similar triangles and triangles with common height. Can I? Okay, so now we practice. Yes, this one I will put up. Okay, this one now is application. So if you are given a full question on vectors, how can we approach the question? So first thing they say, moving from A to B is 6P plus 3Q. So this is 6P plus 3Q. Next one, B to C, because you were like zoning out, is -3P minus 5Q. So this is what they give you. Last one, AD. Okay, A to D is P minus 3Q. I always draw the arrow so I know which direction is going. Vera, tie up your hair. What are you doing in class? Okay, if I want you to show that AB is parallel to DC, yeah.
And then take Q.
Yeah.
Yeah? But so difficult to read.
Yeah, I can't see.
So in order to show that two vectors are parallel, you need to show that they are ratios of each other. So I'm going to write down AB first. So AB is 6P plus 3Q. Why my pen suddenly become...
Maybe it right.
No. Oh yeah, you all say before, right? Okay, but I want it this frame. So I take out the common fact. Okay, maybe I don't take out first, just leave it. Then next one I want is DC. So how to find DC? To find DC, I need to move from D to A to B, and then B to C. So I need to find it first. So DA plus AB plus BC. Can you see the start and the end will be the same station, and then all these will overlap. So I add the vectors up. So DA is opposite of this, opposite direction. So instead of P is minus P, instead of minus 3Q become plus 3Q. Reverse the sign first. Then AB is the same direction, so I just copy. Then BC is the same direction, so I also just copy. Because to move from D to C, I need to move from D to A to B, and then B to C. It's another route to get there. So to find the answer, all the P's you get together is 2P left. All the Q's left 1Q. So this is the vector DC. But can you see that if I take out 3, I get 2P plus Q also? Can I express these two as a ratio of each other? Can I relate the two? Can I relate these two together?
This one, can you answer the question?
Can I relate AB to DC?
Yes, can.
Okay, how to relate them?
DC
AB equals
One.
3AB
One.
equals 1 DC.
AB is equals to 3 times of DC.
Yes.
So if I can show that they are a ratio of each other, therefore AB is parallel to DC.
So if we say DC equal 1, the AB also can.
Also can. So if you can prove that AB is a ratio of DC, or we can say it's a scalar multiple. Sometimes they like to use this word. Scalar just means constant. You can find a constant that multiplies to the other vector. Then it is parallel. So part A done. Okay, part A is done. Part B wants you to find the ratio between AB and DC. So make a guess. If the vectors are in a ratio of this, what should that be?
Just
3
3.
over 1. So actually you can just give me 3 as the answer. Okay, correct, right? You just divide the DC over. Okay, so that's how you find. Okay, they say what if now P represents 4 minus 1 and Q represents minus 3 minus 2. What should AB be? So AB is 6 times of P and 3 times of Q. So just do your substitution. P is this and Q is this. So that's why you need to learn matrices before vectors, because you need to use matrices here. So add them up, you get 15. Okay, so this is vector AB. Okay, lastly, I want to find DC. This one, sorry. Okay, DC I know is this one, 2P plus Q. So I put in my column matrix first. Yeah. Okay, I put in my column matrix. Chloe and Vera, you all keep talking to each other. Rethink about your options. Okay, so once you know the vector already, how to find magnitude? So use Pythagoras theorem. Go and square the x, add up to the square of the y, and then take a square root. 25 plus 16, 41. So you go and find what is square root 41. Okay, 3SF. So this is how a vector question can look like in your exam. Okay, so make sure you know how to translate. I feel like I got lesser people, 2, 4, 6, 20. Who? Jasreal. 3 only what? One more? Oh, Kiran went toilet. Okay. Okay, so vector is a question that can be 8 marks or 9 marks, but sometimes they split 3, 6. That means one question they put in paper 1, the other question they put in paper 2. So make sure you know how to do different types. Yes. Yes. As long as it is vector, must put this the curly tail or the braces. Can? Yeah, I know but you know paper is always a limited resource. Yes, please go. Okay, let's practice the next.
This one, what's the answer?
We press calculator. I don't have calculator. Square root 41.
The answer's 9.
Oh, I have.
The answer's 9.
Rubbish.
It's 9.
It's 6.40. So off. It's very off. Okay, so if you see vectors question, don't be scared. There will be parts that you can do for sure. Okay, next one Justin, you not copying anything, huh? You are in the Google Classroom. Okay, this one. That one no need. It's not us. This one is a chat. One. Oh, not yet. Okay, next one. It says that AEC is a straight line. So let's say if I have a straight line, trying to visualize what they say. AEC is a straight line. AB is parallel to CD. Huh?
They put arrow already.
Oh, I already got a diagram. Okay, sorry. Yes. Question just to stretch your thinking. Okay, AEC is a straight line. So what they tell you is this one is a straight line. And then they say AB is parallel to CD. So they already put the arrow for you, so you know they are parallel. E and F are 2 points on B and G. So it's just lying on that line. And then BE, EF, and FG is in the ratio of 2 is to 5 is to 1. Remember, it's not the actual length, they are units. Okay, and then they tell me that AB is B and AD up to this point, up to this point only, it's D. Okay, so you can draw the arrow so we know where it stops. So they say, can you show that DF is 1/8? So first thing first, I need you to spot the similar triangle. Can you see the stacked triangle here? Where you have a set of parallel line here. Okay, when you can see this stacked triangle, you know the ratio would be the same throughout. Whether it's the base or the sides, it will all be the same ratio. So first thing first, you can tell me that by AA test, triangle GFD is similar to triangle GBA. So that means this one is similar to this one. Why we know? Because if you have two parallel lines, actually these two angles are corresponding angles. These two are also corresponding angles. So by AA test, they must be similar. Do you have to prove it? No need, unless they ask you to prove in part A. So you must tell me they are similar first. So since they are similar, you can find DF ratio with AB to be the same as the ratio of 1 is to 8. Can you all see that? It's the same. The ratio of the sides to the long one, this side to the long one, the base to this will all be the same ratio. So you can first write this down. GF and GB should be equal to FD and, oh no, let's write DF in the direction they want. So DF and AB.
The soap dispenser spoiled.
Oh, okay, I let them know. GD and GA. So these three corresponding sides must have the same ratio. So I want this one because it links to what I want to show. I want to use this one because I have the units. So GF is 1 unit. GB is the whole thing. So if you add 1, 5 and 2 together, it's a total of 8. Okay, the whole thing, I repeat this one. You add the 3 parts together, is 1:8. Then DF, I don't know. Okay, DF, I don't know. Or you want to put the vector there, or can put as vector. Okay, so DF, AB is just B. Can you see that when you cross multiply, you have proven that DF must be 1/8 of B when you cross multiply the B. So this one shown. This is part A. You can ignore because they never ask you to relate to that. So you just need 2 pairs will do. Okay. Want to tie for how long? That's why I always braid my daughter's hair so that she got no chance to untie it in school. I braid, then I tie behind, I braid again so that she cannot take it out in
That's damn
school.
evil.
If not, she will always do her hair.
What if it's really uncomfortable?
No, it's not. She's very used to, with ballerina, right? Always tie the hair very tight like that one. Must draw one line in the middle. I don't understand, but like the balding like that, right? Poor thing. No, you will take a photo. You think I don't know? Never mind. Okay, BG. It's this full line here.
Hey, so Miss Fang, what's your English name?
Ayo, you every day want to distract me with other things. So to move from B to G is the same as moving from B to A and then A to G. Okay, so if I do that, I can find BA plus AG. So how to find BA is the opposite direction of this. So this is minus B. Okay, correct? But I want to have AG, the whole thing. So first thing first, I need to ask myself, this one is how many units? This part here, how many units? This one is D, right? But how many units it represents? Y'all look at the other side of the similar triangle. This one is 1, right? This part here is how many units? 7. So that means this part is also 7. This part is also 1. So to find the whole thing, 7 is 5 plus 2. This one is 5 plus 2. The whole thing is 7 units. So this one should be 7 units also. So if D represents 7 units, how to find the entire 8 units? How to find? Divide by 7 times 8.
You said to find 7 units.
No, yeah. So to find, no, this is 7 units.
Oh, then divide by 7.
Yes. So the D, ayo, now it's thick. Okay, so the D, you want to divide by 7 units times 8. So this is what you get. Cannot. This part here is 7 units.
This one maybe you should fix it.
Here. Similar triangle. If this is 1, this is 7, this must be 1, this must be 7.
But you still need to fix it.
The yellow one I highlight. Can you see the yellow one that I highlighted? My lesson until 12:15.
Yeah.
Okay, fine. Never mind. Let's continue.